All right, so in this lesson, section 1.3, the topic will be evaluating angles between 0 and 360. So really almost the exact same thing we did in our last lesson with just one important difference. All right, in our last lesson, we looked at questions like the following, where we were given perhaps coordinates on a Cartesian plane, and we had to find the trigonometric ratios for those coordinates. So something like sine theta, remember the ratio is y over r, cos theta is x over r, tan theta is y over x. So we had to find those ratios in our last lesson, and all the questions kind of dealt with that. Okay. Well, in this situation, what if we are actually given the ratios, so we don't have to find the ratios, but we're given the ratios, and then we have to find the angle that it corresponds with. All right, so we're going to be looking at something like that. So to do that, before we begin, I need us to recall something. So in our previous math courses, we were able to solve something like this. So I could ask you, if sine theta equals 0.25, what is theta? All right, we're going to need to know this little skill in order to complete today's lesson. So let's try to recap. How do we find theta here? How do we find the angle? If you can recall, all you do, you need to bring the sine ratio here to the other side. And to do that of our equal sign, to do that is you take the inverse of sine for 0.25. So that's the second function button on your calculator. So you would press second function sine, okay, and then 0.25. All right, and for this particular angle, you'd get something like 14.5 degrees rounded off. Okay, so make sure that you can do that on your calculator. I know some calculators might do it slightly different. Make sure that you can get this answer based on the calculator that you have. Now you might ask me, you might say, well, shouldn't this always be a fraction here? We have sine theta equals 0.25, and you might be wondering, like, how's that? That doesn't look like what we did in our last lesson. In our last lesson, we would have had something like sine theta is equal to, let's say, 2 over 5, for example, right? Now remember that this is really just the ratio of the opposite side to the hypotenuse. Well, when you just see a 0.25 here, all this is really a fraction over 1. And what it's saying is that the opposite side is 4 times smaller than the hypotenuse. Okay, so that's what that's saying there, is that if the hypotenuse is 1, call this the hypotenuse, then the opposite side is 0.25, okay, or 4 times smaller than the hypotenuse. So don't be alarmed when you see a ratio like this that doesn't look like it has a fraction, okay? All it means is that, in our case, because it's the sine ratio, that the opposite side is 4 times smaller than the hypotenuse. Okay, moving on. I want us to go over a couple more things actually before we begin the lesson. Is I want you to remember that from our last lesson, we know that sine 58 degrees and sine, let's say, of 122 degrees, that these actually equal the exact same ratio. So sine of 58 is 0.848. Okay, and then sine of 122 is the exact same thing, 0.848. And we looked at why this was, right? And this was because of the cast rule. So we knew, this is just to recap, we knew that this particular ratio exists in 2 quadrants here. All right, in 2 quadrants, and that's because of what's known as the related acute angle. So if you have sine of 58 here in quadrant 1, okay, it would be equivalent to the sine of 122, and the reason being is that 122 degrees creates the same related acute angle as the angle that is here. Now, it also happens to be that these are both positive. Okay, and these are the only two quadrants where the sine ratio can be positive. All right. Again, that is because our y value is in the positive y-axis. And remember that your r, or your radius of your unit circle, is always positive. All right, it's a measurement. It's always positive. It is never a negative value. It's always you're always considered to take the absolute value of a measurement, right? So just remember that this is going to come in handy again in this lesson, that all these ratios occur in two different quadrants. So there's always going to be two different angles that provide the same answer. So keep that in mind. All right. So in today's lesson, we're going to look at something like this, for example. Okay. So something where we didn't do this last lesson. Perhaps I have sine theta is equal to negative 0.25. Okay. And the question could be something like, what are all the angles that, actually from 0 to 360, that will yield this ratio for sine. All right, and so we know now from above that each one of these ratios always has two angles that correspond that will give that exact answer. And so our job now, okay, is not to find the ratios anymore like it was in our last lesson. Now our job is to find the angle. Okay, that's what we're focusing on in this lesson. So last lesson, it was the ratios. It was this half, okay, of our equation there. And now we're focusing on finding theta. And that's why having this knowledge here, what we talked about, and doing the inverse of sine on your calculator will come in handy. Okay, so let's dive right in now. And let's take a look at our lesson. Okay, so starting with some simple examples just to get us warmed up, even though we've already talked about this. It says here, use a calculator to calculate each pair of ratios. Okay, round answers to 4 decimal places. Well, all of these are going to be equal to each other. So sine 58 and sine 122 I already did with you. It's 0.8480. The cosine of 82 and cosine of 278 also equal the same value. Again, this exercise is just to show you that there's always two answers for the same ratio. Okay, and then tan 266 and tan 86. Okay, right there. All right, let's move on. What do you notice about each pair of ratios? They are identical. Okay. Every ratio possesses two angles that correspond with it. Okay? So we've already discussed that. And that is because of the cast rule and the related acute angles. Okay? So this is because of the cast rule and the related acute angles that are created, or beta, okay. So here's some steps summarizing what you need to do. All right. I don't think we should necessarily write the steps just yet. I think as we walk through what we need to do, we'll come back and we'll summarize what we did and we'll write the steps at that point. Okay. And then you'll have a nice set of steps to follow or rules to follow when you are answering the types of questions below. Okay. So here's our first one. it says find the exact value of theta. So again, we are now finding theta, and we are finding the exact value of theta. And as I've said in previous lessons, when you're looking for the exact values, there's almost a guaranteed chance what you need to do is do something with special triangles. Okay? Something with special triangles. We have to find all the answers that provide, well, we know there's going to be two. There will be two angles for each of these ratios here that provide this exact ratio of 1 divided by square root of 2. So let's take a look. What do we do? How do we find theta here? Okay, if your guess is that we're going to end up taking the sine inverse, you're right, but there's a few steps we need to do beforehand because there are two answers. First step, we're going to draw a diagram. What you do is you analyze what's given to you and you say, all right, I have a sine ratio and my ratio is positive. So I have a sine ratio and I have a positive ratio. That means I can only be in two quadrants. Using the cast rule, which quadrants must I be in order to satisfy both of these? I must be here and I must be here. Okay? I know that these related acute angles will be identical, but in order to give my answer, I give the principal angles, not the related acute angles. All right, so I need to find this angle here. Remember that in quadrant 1, beta will be equal to theta in quadrant 1. They're the exact same thing. Okay, and in quadrant 2, I'll be able to find theta by doing 180 minus whatever my beta ends up being. Okay, so you go 180, touch the negative x-axis, and then go back whatever angle beta is. Okay, so we've drawn a diagram. We know we're in these two quadrants. Okay, let's now go ahead and find what beta is. And in order to find beta, what you do is you do exactly what you thought is you do. So let's actually write find beta. You always use the positive ratio when finding beta. So you're probably wondering, but this one is already positive, right? It's already a positive ratio. You're right. Okay, so in this case, it won't make a difference. But when we get to this question, when we find beta, we must use the positive ratio only. So we're not going to consider that it's negative 1 over square root 3. To find beta, the related acute angle, we're only finding it in this quadrant here. And in this quadrant here, okay, we just need to find what it is as a positive ratio. So we go sine beta equals 1 over square root 2. Well, we don't even really need to sub this into or plug this into our calculator. Okay, we don't even really need to do that. Because this is a special triangle, I already know what angle this is going to be. But I mean, you can sub this into your calculator. So you can do, let's say, sine, second function sine, open a bracket, 1 divided by the square root of 2, close your bracket. Okay, and what do you get? You should get 45 degrees. So our related acute angle is 45 degrees. And it's an exact value. It will not be a decimal. Okay? That means that if it's 45 here, that this must also be 45. And so now when I state my answers, remember in quadrant 1 that beta and principal angle theta are the same thing. So my theta 1 is then 45 degrees. My theta 2 is 180 minus 45, okay, which is 135 degrees. For both of these angles, you will get that same ratio, all right, that same ratio. So there's quite a bit there, obviously. quite a few steps that we did. So let's summarize what we did here. All right. We started by drawing a diagram, right? So step one, draw a diagram. Okay, draw a diagram based on the ratio, sine, cos, or tan, and its sign. By sign, I mean positive or negative. Okay? So based on that, we should be drawing it in two quadrants. All right? We should be drawing a diagram in two quadrants, strictly based on the fact that you make note of what type of ratio it is and whether your fraction is positive or negative. All right? That tells you which two quadrants you must be in using the cast rule. So next, okay, is make sure that, of course, I mean, I never really mentioned in the first step, we didn't write it down. We should mention that we should determine the proper quadrants in the diagram, right? So make sure that you just draw it in the diagram. There should be two quadrants in which you're drawing this diagram in. All right. Our next step is we found beta right here. We found beta. So determine beta or solve for beta. Okay. By always finding or using the positive ratio, regardless of what's given to you, whether it's positive or negative, what's given to you. When you're finding beta, just use the positive value. All right, we're finding the related acute angle that's in the first quadrant, and then from there we're applying afterwards how to find theta. So because our last step is determine the principal angles, theta, depending on the quadrant that you're in. It's always going to be different, right? How you find theta. So determine principal angles theta dependent on quadrants. Okay? Let's do this next question. So let's draw a diagram. Step one, right? Let's draw a diagram. We have a tan ratio, and it's negative. So using the cast rule, where do we draw our terminal arms? Where is tan negative? It's negative here, and it's negative here. But we know that these related acute angles will be equal. So we're going to find the related acute angle, and then from there, find the principal angles. Always use the positive ratio. Okay? And then go ahead and find what your beta should be. Okay? So let's do the tan inverse. Okay, so tan inverse, make sure you use a bracket at that point after you press second function tan. Then 1 divided by the square root of 3, close your bracket, and you get 30 degrees for beta. Okay, 30 degrees. So if this is 30 and this is 30, can we now find our theta 1, our principal angle, and theta 2? Well, theta 1 is right here. That's theta 1. How do we find theta 1? If you guessed 180 minus 30, you're correct. And how do we find theta 2? Theta 2 is the angle that goes all the way around to here. That's theta 2, starting on the positive x-axis all the way to the terminal arm. You do 360 minus 30. Okay? There's your two answers. All right, so there you go. We followed the steps. We drew a diagram. We drew what quadrants we should be in based on the ratio and the sign of the ratio. Then we found beta, and then from there we made sense of how to find theta 1 and theta 2 depending on the quadrants that we're in. So you now may be given a question where you're not given the ratio, okay? You're actually just given, you are given a ratio, but you're not given the exact value of a ratio. That just means that you're not dealing with any special triangles now, right? That's all that means. All right, so let's give it a go here. So same rules all apply. We're going to draw a diagram. Make note of two items. First, that we have a cos ratio. Secondly, that it's a positive cos ratio. So now you ask yourself, where do I draw these terminal arms? Where is cosine going to provide me a positive ratio? That's here, and all, and here. And in both cases, beta will be equal. So let's find beta. So let's go cos of beta is equal to, and always use the positive ratio, even though it's already positive, but I just want to reiterate that. Then find the inverse of 0.4151. Okay, and you will get 65 degrees. Now it says to the nearest degree, right? So round to the nearest degree, we got 65 degrees. And now from there, if I know that this is 65 and this is 65, I can now find theta 1. Theta 1 is just going to be the same as our beta, starting on the positive x-axis to our terminal arm. It's simply going to be 65 degrees. Theta 2 is going to be 360 minus 65. All right, so what does this mean, right? Like if you were to sub in cos 65 and cos 295 on your calculator, for both of those angles, you'll get 0.4151. Okay, and our last example here of this particular type, let's draw a diagram. Make note of two things. One being that we have a sine ratio. Secondly, that it is negative. So which two quadrants is sine negative? Here and here. Be careful. Always make beta the related acute angle with the x-axis. This is a common question. You know, a lot of students say, how do you know not to put beta here? Beta is never made with the y-axis. It's always made with the x-axis, right? Always, always, always. So let's find beta using the positive ratio. The positive ratio. Okay, and so rounding to the nearest degree, you get beta is 55 degrees. Well, if this is 55 and this is 55, how do we find, let's start with theta 1. Okay, how do we find theta 1? Well, what if we go to 180, because we know that it's 180 up until the negative x-axis there, and then add another 55, and that takes us to theta 1, which is 235 degrees. Theta 2 is, again, going to be 360, just like the previous question, minus 55, which is 305 degrees. What does this mean? That if you take the sine of 235 and you take the sine of 305, you'll get the same ratio, and the ratio will be negative 0.8219. Okay, our last example here of a different type of question that you might see. Nothing that is any different, but consider an angle, angle A, that lies in quadrant 3, such that tan A is equal to 3.4380. So they're telling us we're in quadrant 3, and to determine the measure of angle A to the nearest degree. So they're telling us we're in quadrant 3. So we just need to figure out the measure of angle A here. Okay, but we're going to follow the same rules, except we're only in one quadrant now. We're in quadrant 3. They told us we're only in quadrant 3. Okay, so we need to find the angle. So we're going to first find beta. From beta, then, we will find our theta, or our angle A. Okay, so let's go with tan of beta is equal to 3.4380. Beta is equal to the tan inverse of that number. Beta is equal to, rounded to the nearest degree, 74 degrees. So if this is 74, we can easily now find theta, angle A. 180 plus 74. Okay, for a total of 254 degrees. And you can check your answer, right? Do tan of 254, and you should get that exact ratio right here. Okay? All right. Now remember, ours is going to be a little bit off because we rounded this to the nearest degree. So it'll be slightly off in your final answer. Okay, so just keep that in mind. Okay, so that concludes lesson 1.3. It's very similar to 1.2. The only difference is we're given the ratio, we're given the right side of the equation, and we have to find the angle.